Thank you for the introduction. Kikuchi from LINE. So I'm going to talk about stamp recommendation using federated learning. First, I'd like to introduce myself. I am a product manager at LINE, mostly product using machine learning. My past experience is security research, like programming language, human-computer interaction research. These are the research that I have been doing, and also geospatial data analysis. At the moment, it's been 5 years since I started working for LINE. So I am going to be speaking about federated learning. What kind of technology is this? I'd like to explain that first. Federated learning. But before I introduce that, I'd like to talk about machine learning that is done on the server side, and there are several examples that I'd like to introduce. The one that is most common is the machine learning that runs on the server side. So we do a model training on the server side of the machine learning process. There are many types of data on the server side. After the training, the machine learning model is created, and that model conducts inference. Inference, for example, is about recommending data to individual users based on the recommended results. And these results are sent to each client, and this is some kind of interaction is done on the server side, and it is once again returned to the server, and there's another training that is conducted on the server side, and the learning or training and inference processing takes place. And this is something that happens every day. Now, the second process is the on-device machine learning inferencing. In this case, the server side only conducts training. The result of the training, the learning model or the training model, is distributed to the client side, and we call that global model because it is common to all clients. The clients has the inference processing. Now, finally, I'd like to talk about the federated learning. So on the client side, machine learning processing takes place on the client side. The clients who participate in the training is just part of it, and their devices or users are chosen at random, and the local models are used, which are going to be uploaded to the server. And those models will have conducted training little by little, so some kind of aggregation on the local model is required, and that result is once again sent to all clients, and all users are able to enjoy the benefits of the training. This is the basic premise of federated learning. And after the inference, the server conducts the distribution. So let me summarize. First, on the side of the server, this is the machine learning processing. There are a lot of computational resources that can be used. For this reason, it is good for recommendation type of processing. The second one is the on-device machine learning inferencing. There is no communication required with the server, so there is no network latency. The user interface is the recommended usage. Finally, the federated learning. In federated learning, the data on the client side is processed on the client side for training. So this means that the data can be reduced, and it is good for privacy preservation. This is on federated learning.
この技術をどの
Next, I'd like to talk about how we incorporated this technology at Line. So this time, the sticker auto suggest is what we worked on. So let's look at the input screen. Say that you would enter arigato, and the stickers, many candidate stickers are suggested. The users will choose one of them and send this sticker. So when you enter yoroshiku, the different candidate stickers are listed. So in selecting the stickers, you can also use the hashtag. So semantic label can be referred to choose the stickers. Now let's go deeper into the actual behavior. So users enter the text. For example, 2 letters ari, and the stickers are recommended. So most of them are meaning the arigato or thank you. If you enter ari, the 3 letters, and the different list of the stickers are suggested. So for each sticker, there's some kind of a semantic label or tag, and is associated to the tag. So when you enter thanks, or if you enter this in alphabets, the same semantic tags are associated with them. So same sticker candidates are recommended. So this is used to understand the semantics or the meanings of the text. So what kind of tags are there? If you go to the Creators Market of Line, you can check what kind of tags are defined. So on this screen, my children created stickers in the past. So those are the examples. So for example, when you say OK, the third tag is appearing. So the multiple tags can be defined. Actually, these are defined in multiple languages. You see the numbers, and that would signify how many languages are provided. In the case of Japanese, there are more than 500 tags. So the tagging can be done manually, but as of now, image analysis is used, and the machine learning can be utilized to guess the tags. Now, talking about stickers, actually, there are different services internally, and here we looked into the premium stickers. So premium stickers, the stickers are defined, but more than 10 million sticker packages exist, and out of them, users can choose and use the stickers. And without downloading, you can also use the stickers. So this time, this is, we believe, suitable for improving the convenience. So what we can use in the premium stamps, there are 2 types. One is the user downloaded one in an explicit manner. And also, the system can also does the auto downloading and make the suggestion. So this time, what we looked into is the auto download for re-ranking. Now, talking about the machine learning, what kind of processes are utilized? I'd like to give you the outline of the different models. As I mentioned, there are 3 different machine learnings. And this time, in order to use it for the service, we use all of those 3 patterns. More specifically, the server side, the candidate generation for each user. This is the candidate generation first stage processing. And as for the client side, the generated the candidates can be shown on the keyboard. So they do the re-ranking. So re-ranking, when the user enters motion, there is an inference, and also the client local data can be utilized for the training. So this requires the federated learning as well. In the first stage, let's look into the content of the first stage. On the left-hand side, from the bottom to the top, let's look at the flow. First of all, as an input, the data which can be utilized on the server, for example, the logo of the downloaded stickers. In addition, the user's features are added. So, for example, gender and the age group, for example, the stickers used by the same age group people could be the effective information. So we also use that. So these data go through the machine learning process and go to the user embedding or item embedding. And this can be considered as an intermediate product. And those two, for example, the user's interest and also the item features, those are the embedded vectors, and actually this is the embedding vector. Usually, when you do use only the server, in the common space, this information is embedded. So two vectors, whether they are similar or not, based on that information, top and recommendation is listed and then distributed to the each user. But this time, the service that we are looking at is the auto suggest. So for each user, the multiple list needs to be created. So when you say Ohio, and you need the list of the certain stickers, and in the case of Yokoso, you need a different list. So hundreds of the lists need to be generated for each user. So the volume of data needs to be reduced. So for that, the clustering on the user data is used. Actually, for each user, the feature is in the user embedded. So for example, through the clustering, the users get divided into thousands of the clusters, and for each there is a common list of the stickers, recommended stickers. So that is what is done by the candidate generation on the server side. Next is the client side. This is the re-ranking. Earlier, when we did the processing on the server, the user embedding and item embedding, those are the input that we use here. So the inference and the training on the client side, we need a machine learning model, which is not shown here, but the machine learning model also needs to be downloaded. Machine learning model has those two vectors. We input those two vectors, and ultimately for each item, which to what extent it matches, we get the score. And this calculation needs to be done through the inference process, and so this needs to be done multiple times. The inference, when the user enters the letter, so after the second letter, when there is a match, then it will be repeated. And for the training, a certain volume of the input and the transmission data, those data needs to be accumulated to some extent. So for the training, the calculation could be very heavy. So this type of processing, when the users are not using the device, when the device is on idle, those processes would be done. So let's compare those two and summarize them. In the first stage, candidate generation, personalization is done for the choice of the sticker candidates. For example, from out of 1 million, top 100 list will be created for the different users. As for the machine learning, the stamp download, for example, the purchase is used as information. Inference and training for both of them will be done on the server side. Second stage, the re-ranking. As I said, the 100 candidates will be re-ranked. And this is for the personalization. And at the time of the re-ranking, as an information, when there is an impression and whether the impression was clicked or not, that kind of information will be utilized. As for the inference, that is done on the client side. And the training using the federated learning, most of the learning, it will be done on the client side. And when the model is integrated, that will be done from the server.
In reality, this machine learning has improved the performance, which will be introduced at the last part of this slide. Next, I'd like to speak about the third topic of the agenda, which is the federated learning that is provided as platform. So I'm sure you have already noticed from my presentation that the system that is developed is on both the server side and the client side. It's rather complicated. This time, the stamp premium that we selected in the future can be utilized for other services. Those are the needs. So we needed to develop this as a platform. The requirements for the platform would be when there are multiple applications, the training must be conducted effectively so that the behavior can be captured. And there has to be a way to separate the client side and the server side. The other is privacy preservation. Each of these models are uploaded separately, so this privacy preservation has to be conducted on the platform side as a common feature. So based on those requirements, this is how the system architecture will look like. First, this is the overall system. The service-specific processing and also another part which is the common platform for the federated learning. Moreover, on the server side, there's a server-specific client-side processing. So in fact, there are 4 or quadrants in the system architecture. As I explained earlier, the first stage and the second stage processing, on the side of the server, the machine learning or the candidate generation would be on the left-hand quadrant, whereas the re-ranking, the model itself is simple, but since there are multiple processing, so this is going to look like as indicated in the following slide. The system architecture. So on the side of the client, the re-ranking processing is conducted on the application side and the platform. So the user will do some kind of input, and depending on that result, the client application will do a prediction request. That request will act in the same way to generate the inference on the application side. The inference is like this. On the other hand, training. As for training, so the user does the input, the input, and impression is generated. That information is like sending a log to the server. So inside the client, the log is sent to the platform. That is the processing. For this reason, the data sent needs to be aggregated, and when should the training occur is something that the application side does not need to know. So looking inside the inferencing side, so we need a platform that will support the server side. And it's not indicated in this diagram, but the users or the item embedding, these types of processing is very specific. So it is done on the left-hand side, a client-side application. As for training, when the log is generated, the client application side does not have to worry about the content, and the log is sent to the client platform. And when the log accumulates to a certain amount, and at the timing of appropriate training, the processing of the training is conducted, and that is uploaded on the server. And when that is accumulated on the server side, the aggregation is done, and a global model is generated. The global model, regardless of whether the training has been done or not, will be used as inference by the clients. So other features that the platform supports from the top. First, there is a feature that does A/B test. In addition, so the correct inferencing on the model side is determined by the version training. Model training is done on the back side, and the model, which might become multiple models in the future, that time of training for the model is determined by the scheduler. Also, the machine learning model has the supports both iOS and Android, and for this we use Onyx for OS agnostic. So this circled section can be explained tomorrow, so please attend that presentation tomorrow. Mr. Hyuk-jae from Korea is going to speak about the client platform for supporting multiple federated learning instances.
So let me now talk about privacy. From the privacy preservation aspect, the platform that we have developed takes two different approaches. The first is that the volume of the data receiving on the server side needs to be minimized, and the differential privacy should be able to applied. Now, as for the components of the differential privacy, after learning the model, as a post-processing, it is included. So locally, the differential privacy is applied. So here it says local DP. Now, what is the differential privacy? In federated learning, we are applying this, so let me talk about that. On the local devices, the users does some kind of operation, and then there are logs. And after the logs accumulates, and there are training, and the raw data will be converted to the training data, and that is the aggregation and transformation, which are shown in gray here on this slide. Now, the differential privacy, we also have a noise injection. Now, the differential privacy itself, statistically, how the privacy can be protected is shown. So it's a kind of a standard, and in order to comply with the standard, noise is injected. So the machine learning model with the noise injection from the other users, the similar noise model, we will not be able to distinguish between the two. So the strength of the noise is controlled by the parameter called epsilon. And with the noise, the original data we do not know the original data. So what kind of stickers were seen by the user will not be able to inference. So the server side, we have a data with noise. So in the federated learning, differential privacy is applied to the model like this. About the differential privacy, when you apply this, currently our status is shown here. First of all, the federated learning and the differential privacy are combined. So we need to configure a system, and we made a certain progress here. Internally, Gaussian mechanism is used. And this is the differential privacy technology and also the federated learning used on the server. Simply, we do the weight average. So federated averaging is used. And also the training model, when we need to integrate it, we don't need to use the user data. So when you upload the data to the local, you would send it without the user ID. At the same time, from now on, for the R&D, we would need to work on this. So privacy parameter epsilon needs to be set at the appropriate level. As of now, the system configuration is complex, so we are checking the overall health of the system so that we can check whether the training can be completed. So the small noise is currently injected based on the parameter. But as the training goes on correctly, we have to also consider looking for the appropriate parameter. Let me summarize. I'd like to introduce the result of the A/B test. So 5.6% uplift was observed. So what does this mean? The premium stickers were discussed, and when the users explicitly download this, to what extent did we see the increase of downloading? At the time of the A/B testing, we looked into the difference, and the stickers who are shown using federated learning or not, that is the difference that we looked into. So 5.6% uplift of the user means that after the suggestion, the users liked it, so they downloaded it. That is the meaning of this 5.6% uplift. But for us, whether this is sufficient or not, I think there's much room for improvement. So in the area of the machine learning, first stage and second stage, we need to improve both of those stages. Now, this time, the system that we developed internally had the support and collaboration from many people internally. So as you can see, when we superimpose the system architecture, the three sites were involved: Tokyo, Fukuoka, and Korea. In those three places, the languages used in Japanese and Korean and English, three different languages. And those people actually who were directly engaged was about 30. And also those people who have done the security review and the privacy research and other communication people and the reviewers in the area of the security, many people helped us. So this we faced a lot of difficulties, but our target was very high. So engineers worked very hard, and I think we developed something very good. So I'd like to thank all the liners who worked with us, and I feel very proud of them. Now, as for the future work, the sticker premium was the service that we looked at. But actually, in the keyboard, there are some stickers that you have purchased. So the re-ranking, we want to expand it into the other stickers, and we also would like to increase the number of the users. And the privacy technology, we want to apply and operate correctly. And that is something that we also want to achieve. the LDP parameter needs to be set correctly. And also the shuffling is a technology that we can introduce so that we can make sure that the privacy can be protected. That concludes my presentation. Thank you for your attention.
Thank you very much, Mr. Kikuchi. We're going to do a plus talk. The questioner is going to deep dive into the presentation. We will also try to accept your questions as much as possible. If you have questions, please click on the question button at the right hand bottom of your screen. The questioner is going to be Mr. Takashi Miyazaki of Yahoo Japan. Please turn on your camera. Can you please introduce yourself, Mr. Miyazaki? My name is Miyazaki from Yahoo Japan. I do data integration. I am in a section called AI integration. I do a technology survey and that type of work. Thank you very much for this opportunity. Mr. Miyazaki, what are some of your questions from this presentation? So, Mr. Kikuchi, you spoke about federated learning and also language training. It was very inspiring. Thank you very much. I have a lot of questions, but the first question is about federated learning. I think it's becoming more and more well known today. So as a product, it's being launched or released. I think it's very rare that something like this is being released. So what made you start to develop this kind of system? Thank you for your question. So federated learning launch. This is something that I had always wanted to do. In reality, in 2018, 2019, going back to those years, the people in the security asked me, would you like to try this? This was the first time that I heard about this concept. And this time, I became involved in development because the stamp premium business unit wanted to improve this function. And they wanted to do this by utilizing federated learning. So the stamps are recommended to the users. If you're just trying to personalize that, the technology option is not necessarily limited to federated learning, but we wanted to federated learning and we got the sponsor. So this is why we were able to challenge developing this system. So the technological side, it's not just the wish of the technological side, but the server side. I think they also wanted to do this. I suppose it kind of matched. Now, the federated learning platform is being developed by your team. There are many engineers are involved, and they all have their own expertise. So when you are trying to get together members of this team, how did you do that?
Well, this time, within LINE, managers and also the senior managers, they originally were the engineers. I think that was a very important factor. They had a very good understanding, and they said that this is the area that we need to invest in at this timing. So they gave us the development resources. Another thing is that already in LINE, not particularly for the federated learning, but something that we can use. There are functions and technologies, many of them existed, so we could combine them to use. So there were fundamental technologies that existed across the different organizations. So when we combined them, we also easily found the people who can help us. I see. Thank you. So there were this technological development already available. I see. Also, the federated learning, the technology itself, there are in the production, I think there is only limited the services which were already provided. So when you faced the difficulty, how did you overcome them? Are there anything that you did in particular? Well, the challenges, issues, technologically, I cannot really think of any major ones. The ones that I introduced today, mostly we used the ones that we knew would work. So on the server side, with the data that we had a simulation, and we knew that it would work to some extent. And the difficulties, the technologies, for example, we are dealing with the privacy. So how do you communicate with who to explain this complex system and the value of it? So the number of stakeholders increased. So that led to some difficulty. But as a result, I think that we had many discussions and we could create something good. I see. Thank you. Well, we received some questions through chat function. On the device, we do the training. So when you change the device, the log data, whether that's inherited, or for example, iPad and iPhone, when you use both of them, are they integrated? So we received the question like that. Well, first of all, the inheritance among the different devices, the federated learning on the client side, the input is the user embedding and item embedding and the model. Those are the three. And the models, these are the global models which are distributed. So they're not dependent on the devices. So as for the users, what's inherited is the user embedded vector, and they are generated on the server side. So in that sense, the devices, when the devices are changed, the operation can be done in the similar way. So as for the second device, internally we had some discussion and say that the same user uses multiple devices and collecting data and uploading it to the server. There could be some privacy issue that came up in the discussion. Especially, we send it to the server without the user ID. So intentionally, we cannot reduce the amount of the data. So second device, for example, iPad, tablet, or PC, on those devices, the training is not done. That is how we made the judgment. So I see. So you thought about this and decided on the specification.
Also, another question. There are several questions. This time, on the system side, on the server side, federated learning system on the server side. Well, you have the server and the client, and they receive training together, more or less. So the clients who are connected, are they simultaneously connected to attend the training? Is it like a synchronized type of training, or are they able to connect separately to receive the training? What is the scheme? Well, actually, it's asynchronous. That is the image. So the client side, well, it's going to be explained in more detail tomorrow in a different session. The device, when the device is idle, the training process is done. So the training schedule and when that data is going to be uploaded on the server, that's not done on the live side. Android iOS side does that. Therefore, the server side, by best effort, will, for a certain period of time, aggregate the results of the training of the users, and then the final distribution is done after further aggregation. I see. So it's an asynchronous approach. I see. Okay. Thank you. And the model, how often do you update the model? Well, it depends on the number of users. So at this point in time, it's a little difficult to say how often, but relatively, it's quite frequent. The A/B test, when we do the A/B test, part of the users can use the existing service to a certain extent. So after the release, the more users who use this system, we will have more training sessions. So we want to make it into a service where more and more users will be using. Thank you very much.
じゃあ最後の質問にさせて。
The last question. At the end of the session, you talked about the future work. So this was developed as a platform. So how you develop this further? Are there any ideas about the future development? If you can tell us as much as possible. Well, together with the engineers, I work together with them. So the function like this, we want to, of course, include and apply this to the other applications of the line. And of course, that the question of the privacy has become a hot topic. So we are investing in this area. And the researchers reading the latest paper is researching on the latest introduction of those technologies. So protecting user privacy and with those technologies, and we want to increase those opportunities. And are there any next services or the systems that we are targeting for the future or not? We are still not in that stage. So from now on, we will be developing the new service, and we are hoping to do so. And about the public communication, I think is very important. So concerning that, we would like to look at the trend in the society and make correct decisions. So that's something that we would like to do. So that's as far as I can discuss. Thank you. Thank you very much. We look forward to the further development, and thank you very much for your presentation today.